Welcome to the Public Exam Review on Chapter 8, Dealing with Logarithmic Functions. In this presentation, we will use the laws of logarithms to complete various examples of logarithmic expressions and equations. Throughout this presentation, we will focus on using the laws of logarithms to write equivalent logarithmic expressions. We will also use the laws of logarithms to solve exponential equations with different bases, as well as solving some simple logarithmic equations. The laws of logarithms are as follows. The product law states that the log of a product can be rewritten as the sum of two logs. The quotient law of logarithms can be rewritten as the log of a quotient can be rewritten as the difference of two logs. And the power law of logarithms can be written such that the exponent can be written in front of the value of p, put in front of the log of m. So we have log of m raised to the power of p equals p times the log of m, maintaining the same base of c throughout. So let's look at some examples where we would use the laws of logarithms. If p is equal to the log of 8 to base 3 and q is equal to the log of 6 to base 3, write the log of 8 root 6 to base 3 in terms of p and q. So here we have the log of 8 multiplied by the root of 6. Notice that that is the log of a product. So we can rewrite that as the sum of two logs, namely the log of 8 plus the log of the root of 6 with a base of 3. So then we can change the root of 6 to be a fractional exponent. We can get rid of the radical by writing the root of 6 as 6 raised to the power of 1/2 to the base of 3. Then we can use the power law of logarithms and move the 1/2 in front of the log of 6 to base 3. Now, if you notice what we were given up above, we were told that p is equal to the log of 8 and q is equal to the log of 6 to the base of 3. Therefore, the log of 8 to base 3 can be written as p plus 1/2. The log of 6 to base 3 can be written as q. So your final answer here would be p plus 1/2 of q. In the next examples, we are asked to solve for x in each case. Notice here that we have an exponential equation with different bases. So in order to solve this equation, we need to begin by taking the log of both sides of the equation. And now we can use the property law of the power law of logarithms to move the exponents in front of the log. So we have x plus 1 multiplied by the log of 4 to equal 2x multiplied by the log of 3. Notice here that there is no base given to your logarithm, so we know that it's a common logarithm with a base of 10. This can be, you could use your calculator to evaluate these logs. So x plus 1 would be multiplied by the log of 4, and we remember to use 4 places after the decimal. So it's decimal 6021 is approximately equal to 2x multiplied by the log of 3. And on your calculator, the log of 3 is decimal 4771. I'd just like to say here that it's important to use 4 places after the decimal, because the less rounding off you do, the more accurate your answer will be. So we use 4 places after the decimal. Now what we have to do is we have to take the x plus 1 and multiply it by decimal 6021. So that means both of these terms have to be multiplied by decimal 6021. So that then results in decimal 6021x plus decimal 6021, which will approximately equal, and 2 multiplied by decimal 4771 is equal to decimal 9542 in front of x. So now in solving for x, we bring all of the terms containing x to one side, and we bring the constant terms to the other side. Decimal 6021 minus decimal 9542 is equal to a negative decimal 3521. That will be the coefficient of x, to approximately equal a negative decimal 6021. And then we will divide both sides of the equation by a negative decimal 3521. And the value of x then is approximately equal to 1.71. We can round off to 2 places after the decimal as our final answer. Now, in the next example, we again are asked to solve for x, and we will use the laws of logarithms to do so. So here we have a 2 in front of the log, so that can be rewritten as the log of x squared to the base of 3 minus the log of x minus 2 to the base of 3 to equal 2. Notice on the left-hand side that we have the difference of 2 logarithms. So now we can use the logarithm of a quotient. If we have the difference of 2 logs, that can be rewritten as the log of a quotient, x squared divided by x minus 2 to the base of 3 is equal to 2. In order to solve for x in this example, we have to switch this from logarithmic form to exponential form. So you have 3 squared is equal to x squared divided by x minus 2. Cross multiplying, we have x squared is equal to 9 multiplied by x minus 2. So x squared is equal to 9x minus 18. Bringing all terms to one side of the equation, you have x squared minus 9x plus 18 is equal to 0. Notice that this equation can be factored. The factors of a positive 18 that have a sum of a negative 9 are x minus 6 times x minus 3 is equal to 0. So in order to complete this solution, I'll just move here to the right a little bit. So we have x minus 6 is equal to 0 when x is equal to 6. And as well, we have x minus 3 is equal to 0 when x is equal to 3. We also need to check for extraneous roots here. So remember that you cannot take the log of 0 or the log of a negative number. So when we substitute in 6, in the first case you would be taking the log of 6, and in the second term you would be taking the log of 4. Both of those work out to be okay. Then you take the log of 3 and the log of 1, so it seems here that both solutions are acceptable. Let's look at some potential questions that could be asked on the public exam as multiple choice items. Here we are given that the log of 3 is equal to x, the log of 5 is equal to y, and the log of 2 is equal to z. Express the log of 45 over 2 in terms of x, y, and z. Notice here that we are given the logarithm of a quotient. So that can be rewritten as the difference of 2 logs, the log of 45 minus the log of 2. The log of 45 can be, the number 45 actually can be rewritten using multiples of 3 and 5. That's what I'm looking at there. So I'm saying that 45 can be rewritten as 9 times 5 minus the log of 2. Then you have the log of a product. So you can write that as the log of 9 plus the log of 5 minus the log of 2. Just keep in mind what we are given here. You have the log of 3 is equal to x. The log of 5 is equal to y, and the log of 2 is equal to z. So I would like to take the number 9 and rewrite that as 3 squared plus the log of 5 minus the log of 2. So then the 2 can be rewritten as the coefficient in front of the log. So we have 2 log 3 plus the log of 5 minus the log of 2. And now when we substitute in the values for x, y, and z, we have 2x plus y minus z as our final answer. And this corresponds with A as the multiple choice item. So the log of 45 over 2 is now written in terms of x, y, and z. In example 2, we are given that the log of y to base 2 is equal to 1/2 the log of x base 2 minus 2 times the log of 3 to base 2. We are asked to express y in terms of x. So again, let's use our laws of logarithms. So we would have the log of y to base 2 is equal to, we will take these coefficients using the power law of logarithms and make them exponents. So 1/2 the log of x base 2 can be rewritten as the log of x to 1/2 to base of 2, and the 2 log 3 can be rewritten as the log of 3 squared to base 2. So now we have the log of y to base 2 is equal to the log of, we could change the x to the 1/2 to be a radical. X to the 1/2 is equal to the square root of x, and we know that 3 squared is equal to 9. On the right-hand side, we have the difference of 2 logarithms. So that can be rewritten as the log of a quotient, the root of x divided by 9 with a base of 2. Now we use another rule for logarithms. If we have the log of m to base c equals the log of n to base c, so you have 2 logs are equal with the same base, then we can conclude that m is equal to n. So in this case, you have 2 logs on each side of the equation of the equal sign. So you can now conclude that y is equal to the root of x divided by 9 as your final answer. So this corresponds with D as our multiple choice item. In example 3, what is the value of x? And notice in all 4 multiple choice items, they are giving us the exact values of x. There are no decimal approximations here. So once again, we will use our law of logarithms to solve this equation. We begin by dividing both sides of the equal sign here by 3. So that results in 5 raised to the power of x over 2 is equal to 12 over 3, which is just equal to 4. Notice that we have an exponential equation with different bases. So we begin by taking the log of both sides of the equation. The power law allows us to take the x over 2 and put it in front of the log of 5 to equal the log of 4. In order to get rid of this fraction x over 2 here, we can multiply both sides of this equation by 2. So if you multiply by 2, that results in x times the log of 5 is equal to 2 times the log of 4. In solving for x, you will divide both sides of that equation by the log of 5. So your exact value for x then, x will equal 2 times the log of 4 divided by the log of 5 as our final answer. And this corresponds with D as our multiple choice. In the next example, again we are asked what is the exact value of x, where 7 is equal to 2 times x plus 1. So here we have an exponential equation with different bases again. So we need to take the logarithm of both sides. So we have the log of 7 is equal to the log of 2 raised to the power of x plus 1. We take the x plus 1 and move it in front of the log of 2. So now we will divide both sides of this equation by the log of 2. When we divide both sides by the log of 2, we are left with the log of 7 divided by the log of 2 is equal to x plus 1. And in order to solve for x, we subtract 1 from both sides of the equation. So we are left with the log of 7 divided by the log of 2 minus 1. That is our exact value for x, and this corresponds with D, again, as the multiple choice answer. In example 5, we are asked to solve for x again. Notice that this time we are just given decimals, but the process is still the same. In order to solve for x, we need to begin by taking the log of both sides of the equation. The log of 2.65 raised to the power of x is equal to the log of 398. We can move the x in front of the log of 2.65 is equal to the log of 398. Then we will divide both sides of this equation by the log of 2.65 in order to solve for x. Notice that this is a common logarithm with a base of 10, so then the value of x, the exact value, would be the log of 398 divided by the log of 2.65, and when you work that out on your calculator, you will get x to approximately equal 6.143. And this answer then corresponds with C as the multiple choice item. In example 6, we are asked to solve for x. We have the log of 2x base 7 plus the log of x minus 3 base 7 equals the log of 8 to base 7. On the left-hand side of that equation, notice that you have the sum of two logs. So that can be rewritten as the log of a product, namely 2x multiplied by x minus 3 to the base of 7 is equal to the log of 8 to base 7. If the log of m is equal to the log of n, notice that we have two logarithms are equal with the same base. Therefore, we can conclude that 2x multiplied by x minus 3 is equal to 8. Multiplying throughout, we have 2x squared minus 6x. We can bring the 8 to the left-hand side and make everything equal to 0. We can tidy up that equation by dividing throughout by 2. So we are left with x squared minus 3x minus 4 is equal to 0. This equation can be factored as x minus 4 multiplied by x plus 1 to equal 0. We'll continue to finish that solution on the other side. So that x minus 4 is equal to 0 when x is equal to 4. As well, x plus 1 is equal to 0 where x is equal to a negative 1. At this point, we need to check for extraneous roots. So when x is equal to 4, we are actually finding the log of 8 in the first case and the log of 1 in the second case. So that means that x equals 4 is an acceptable solution. On the other hand, when we check x equals a negative 1, here we will be taking the log of a negative 2, and here we will be taking the log of a negative 4. Since you cannot take the log of a negative number, it is important that you reject x equals a negative 1. So your only solution in this example is x equals 4. And in example 7, if f of x is equal to the log of x to base 2, which statement is true? So in part A, we have f of a plus b equals f of a plus f of b. Let's just check each one of these answers to see where we would come up, or what solution we could come up with. So if we know that f of x is equal to the log of x to base 2, then f of a plus b must equal the log of a plus b to the base of 2. Right? Wherever there's an x, you will substitute in a plus b. So the log of x becomes the log of a plus b to base of 2. f of a is just equal to the log of a to base 2, and f of b is equal to the log of b to base 2. And we can note there that the log of a plus b does not equal the log of a to base 2 plus the log of b to base 2. So that eliminates a as a multiple choice item. Let's look at part B. For part B, you have f of AB. f of AB is equal to the log of AB to the base of 2. And we know already that the f of A is equal to the log of A to base 2. And we know that f of B is equal to the log of B to base 2. And therefore, we have the log of AB to base 2. We know that that does not equal the log of A to base 2 multiplied by the log of B to base 2. Because if you think about your product law of a logarithm, the log of a product should be the sum of the two logs. And here we got the product. So that eliminates B as a multiple choice answer as well. Let's look at part C. We are looking at f of a minus b. f of a minus b is the log of a minus b to base 2. And note that that does not equal, we have already had f of a equals the log of a to base 2, and f of b is equal to the log of b to base 2. And we know that the log of a minus b to base 2 does not equal the log of a to base 2 minus the log of b to base 2, because the difference of two logs should be the log of a quotient. So that eliminates C as a multiple choice answer. So hopefully D will work out for us. In part D, we are looking for f of a over b. So that's equal to the log of a over b to the base of 2. And we've already determined that f of a is equal to the log of a to base 2, and f of b is equal to the log of b to base 2. And we do know that the log of a quotient, a over b to the base of 2, is equal to the log of a base 2 minus the log of b to base 2. So it appears then that D is the correct answer for this multiple choice item. The log of the quotient is equal to the difference of the two logarithms. So that would be our final answer for this multiple choice item. As a summary then, we have used the laws of logarithms, and I should state to you that these laws of logarithms are not provided on the formula sheet for your public exam. You are expected to know them. So I strongly encourage you to remember these product laws, the quotient laws, and the power law, and it's important to know how to apply them. So we have the log of a product can be rewritten as the sum of two logs. The log of a quotient can be rewritten as the difference of two logs. And if you have the log of a power, then you can take the exponent and move it in front of the logarithm. Another property that is frequently used is that if you have the log of m equals the log of n, maintaining the same base of c, then we could conclude that m is equal to n. Thank you for your time and your attention. Good luck as you continue with your review.